come to a section probability. Probability is wide. So we're going to look at the first segment of probability, which is called conditional probability. So today I'll just look at 4 axioms of probability, which are 4 to 5 axioms of probability. The first one is a range within probability must range. Simply says probability must range between 0 and 1. Meaning you cannot get anything more than 1 or anything less than 0. Meaning you cannot get a negative. The next one is the probability of a union set. A union B is simply the probability of A plus the probability of B minus the intersection. So to unite is to add. If you're looking at 2 probabilities, A and B, where they meet is the intersection. But when you add them, you will remove the intersection to avoid duplication. Then we have what is called the complement. The probability of A plus the complement of A will always give us 1. Yes, Shifundo, you have a question? Yes, please. There's a hand up. You can ask. Okay, I assume that is a mistake. So probability must always add up to 1. So if A is 20%, the complement of A must be 80%. Then we have what is called Bayes' theorem. Bayes' theorem is a pattern. If you have A given B, the probability of B will go down here, and you're going to intersect A and B. This is a pattern. So it follows that if you have B given A, what does it become? What goes down? The probability of A. Then on top, we're going to have probability of A intersection B or B intersection A. So this is what we call Bayes' theorem. Bayes' theorem. Now, based on this theorem, these 4 axioms, I will look at the following question. If our probability of A is 0.4, probability of B is 0.3, and probability of A given B is 0.2. We shall find the following. Number 1, let us find the probability of A intersection B. Secondly, we'll find the probability of A union B. Then we'll find the complement of A and the complement of B. In that order. So I'll be as basic as can be. So how do we find whenever a given conditional probability, you first expand it. So A given B, who can help me expand? What goes down? Probability of B.
To be probability that B, probability of B there.
And on top, what are we going to have?
Probability of A and B or B and A.
So we're given A given B as 0.2. The intersection is what we're looking for. And we're given probability of B as what?
0.3.
Then you first multiply 1 times A intersection B. Let's find A intersection B. 0.2 times 0.3, we're going to get what? 0.06. That is how we find A and B. Intersect is to multiply. Are we together? Okay. So who remembers how do we find A union B? A union B, probability of A, probability of B minus what? The intersection of A and B. So we've been given the probability of A as 0.4, B as 0.3, and finally the intersection that we found as 0.06. What becomes our answer? We find 0.64. The complement of A is the opposite of A. So if A is 40%, the complement is 1 minus A, so which is 0.60%. If B is 0.3, the complement of B is 0.7. The two must add up to 1. Can you remember? Now need you to participate. We're given probability of B given A as 0.3. Probability of A as 0.4. Probability of B as 0.5. Anyone could lead us into the probability of A intersection B? What is the probability of A intersection B? Our classes are interactive. For those of you who joined us today, usually are very interactive. So how do we find the probability of A intersection B? The first thing is we expand this. Who wants to expand this for us? What is probability of B given A?
The probability of A at the bottom.
The A will go down.
Then probability, yes. Then on top you have probability of A or B and the other. So
other
probability of B, yeah, A and B, yes.
Great. So what is B given A?
Mm-hmm.
0.3. A intersection B, we don't have, right? And what is the probability of A?
0.4.
4.
4.
And when you cross multiply, what do we have? A intersection B is therefore equal to what? 0.3 times 0.4. What do we get? 0.12. Okay, now the ladies, A union B. Ladies, A union B. How do we expand A union B? A union B. The ladies, A union B. How do we expand that? Grace? How do we expand A union B? It's probability of A plus what? probability of B minus what? A intersection B. So what is our A? 0.
A
What?
is 0.4.
And our B?
It's 0.5
And the intersection?
minus 0.12.
What do we get?
We get negative 0.22.
Can be negative.
Oh, sorry, no. We get negative 7.8.
It's not negative, so it's positive.
Or positive 7.8.
0.78.
Yeah.
Okay, who wants to help us find the complement of A and the complement of B? Complement of A is 1 minus A itself. So what is our A? Zero 0.4. Then 1 minus A, we get 0. What? 0.6. It's just the opposite of what you have there. What is the complement of B? One minus probability of B itself. So our B is 0.5. So 1 minus 0.5, it still gets 0.5. Is anyone lost this far? The same principle can be extended to contingency tables, where you're given A, B, X, and Y. So here we have 2, 4, 6, 8. The first thing you need to do is to total up. So the total here is what? 8, 4, 6, and 14. So the total of totals is 20. So how do you find the probability of A? Is the number of A elements over the total of totals. So the total of A is what? 6. 6 out of 20, which is 0.3. So can somebody lead us? What's the probability of B? What's the probability of B? The total for B is what?
8 over 20.
Over 20, which is 0.4. Probability of X?
X is 14 over 20.
14 over 20. Okay. Which is 0. What?
0.7.
0.7. Then Y?
Y is 12 over 20.
4 over 20, correct? Which is what? 0.6.
0.6.
So intersection, when I say A and B, and means intersection. Where do they meet A and B?
On 2.
So you go to 2 over what? 20, which is 0.1. So you tell me what is X and Y. the same as probability of what?
X and Y.
So
8/20.
you go and check where they meet X and Y. They meet where?
8.
8. So we're going to have 8/20. 0 point what? 4. Then when we say A or B, or means what? Union set.
Union set.
So who remembers the formula for A union B? Probability of A
Plus
plus
probability B minus A union or A union B.
so what is the probability of A?
2/.
We have A 0.3. What is the probability of B?
0.4.
0.4. And that's the intersection of A and B. We found that 0.1. So our final answer will be 0.what? 0.6. So I'll give you a chance. I hope you have your papers there. A or X or Y. Find X or Y.
0.7 plus 0.6 minus 0.4.
What do you get?
0.9.
Correct. Now let's go to an exam setting. When you're given such a question. So we're told that the data shows the number of cars of various types of at the local dealership. So we have the new, the used, the sedan, and the used USB. What did I say was the first thing you do when you're given this? You get the totals, right?
Make total. Yes.
What's the total here?
33.
33. Here,
27.
37. And here,
39.
39.
39. Then here,
21.
21. What's the total of totals?
60.
16. Correct. Okay. So capture that. So to give me the figures as I take on the worksheet.
Shouldn't it be 27 instead of 37?
So here, what did we have here? We had what? New. Those who captured it. Here we had new. Here we had what? Old. Okay, then we had the new and what used, right? Then here we had what? Sedan and SUV. We're given 24.9. Then 15.12. What was the total here? 33. Here, what was the total? 27. Here, 21. And there, 89. We had 60 there. So, one at least say something from what we've learned. What is the probability that a car that was selected was new? What's the probability new?
Probability is 39/60.
9/60, which is 0. What?
Zero 0.65.
0.65. Correct. Next, tell me the probability that the car selected was a sedan. Somebody else, probability sedan. What?
It's 33/60.
3/60. Which is 0. What?
55.
0.55. Next, the car that was selected is a new sedan. It should be new and sedan.
(24/60).
New and sedan. So it is simply probability of what? New intersection sedan.
Intersection sedan.
So where they meet, what do we get?
24/60.
And 4/60. What are you getting?
0.4.
0.4. Okay. Then finally, find the probability that the car was either used or SUV. What do we do there? Probability what?
Used or
Used or SUV. Or means what?
intersection.
Are you sure?
Union.
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 That's the union.
Exactly. So this is probability of what?
Probability of used plus probability SUV
SUV.
minus probability new intersection CSU.
So what is the probability of used? 21/60. SUV. 7/60.
29/60.
Intersection of used and SUV. 4/60. Okay. Then you can find the answer. Interesting. Can you fail to do this in the exam?
The only part of the exam I will say no, not anymore. I wouldn't fail.
What? But you've seen such questions because you don't understand the basic concepts in it.
Yes.
All right. So So sometimes you'll be given probability of A as 0. Maybe 0.3. Then we have probability of B as 0.7. And given D, given A, and here given probability of D, given B. Okay, let me change the figures here. Suppose this is A is 0.4 and B is 0.6. And here D given A maybe 0.10 and this is 0.04. So using a tree diagram, find the probability of D, find the posterior probabilities, which are the opposite. A given D, and also probability of B given D. So you can use a tree diagram to illustrate this. Okay, so they are what we call prior probabilities. They always add up to 1. So probability of A there has been given as 0.4. The remainder, probability of B is 0.6. And here they've given you D coming from A. So D given A. What is the probability? 0.10. And again here given D coming from where? B. D coming from B is 0.04. From the initial that we had, remember we had said if A given B is equal to A intersection B over B. If you cross multiply this one, as long as the bottom guy is the multiplicand here, you get an intersection. I need to teach you this shortcut. A given B, if it kisses the bottom guy here, B, ultimately you get the intersection of A and B. So let me ask you a question. What do I multiply B given A to get an intersection? What do I multiply B given A to get an intersection of A intersection B? Someone?
A.
A, exactly. Great. If I had X given Y, what do I multiply this one by to get the intersection of X and Y?
Why?
Why?
Exactly. So you need to understand these principles for you to enjoy this. All right. So in essence, the other thing you need to understand is Theorem 2, which says if you have common letters A intersection B plus A intersection C, you pick the common letter. What letter is common here?
A.
A. So it will be A. How about if A intersection D plus C B intersection D plus C intersection D. When you add all this, what probability are you getting? C intersection D, sorry. When we add all these probabilities, what probability are you getting? The common letter, which is what?
D.
D.
Are we clear so far? This is called Theorem 2. Now, tell me, if I multiply these two guys here, I know I'm going to get 0.04. But what is this probability called? The probability of what?
A bit of A.
D intersection A. Remember, the multiplicand here is one multiplying. You're going to get the intersection of these two. This slash becomes what? An intersection. So tell me, if I multiply these two, what am I going to get? Probability of D intersection what? Right, 0.6 times 0.04, I'll get 0.024. So if I add these two, D intersection A plus D intersection B, the total probability will be probability of what letter?
D.
Good. D, because it's a common letter. So we're going to get 0.064. So this is our probability that we get. Questions so far? Now, how do we find A given D and B given D? A given D. Who wants to expand for us? Derek, what letter goes down?
D.
And on top we're going
D
to
at
have
the bottom. A intersection D.
so do we have A intersection D somewhere here? Yes, the same as what? B intersection A. What did we have? 0.04. So put 0.04. And probability of D was 0.064. Was it? 0.064. Okay, what was the probability of B? How do you find probability of B given D? What goes down?
D.
D.
And on top we're going to have what?
Probability of B intersection D.
We have B intersection D.
Probability of B.
We have it? Yes. Which is 0.024. So 0.024 over 0.064. And you find your answers in there. So this one came in your exam. Now, how did it come in your exam? came like this. Question came like this. I'll just pin it for you here. We're told that two machines are producing the same item. Last week, machine A produced 40% of the total output, and machine B the remainder. So machine A produced how much? 40%. So A is 0. What? 0.4.
4.
Meaning what is B?
0.6.
How did you get 0.6?
I subtracted 1 from 0.1, 0.4.
You get the remainder, right?
Yes.
Then on average, 10% of the items produced by machine A were defective. So defective coming from where? A. What was the percentage? 10%. This is 0.10. And 4% of the items produced by machine B were defective. So defective coming from where?
Machine B,
What was the percentage?
0.4.
0.04%.
0.4.
That's one. What proportion of last week's entire production was defective? So they're asking you to find probability of what? They're asking you to find probability of D. All right, which we found here. Probability of D is by multiplying this by that to get the intersection, this by that to get the intersection. Then when you add the two intersections, you get the probability of D, which is 6.4%. See how tricky it was?
Yes.
If you don't understand how to apply this, then lastly, you ask if an item is selected at random and combined from the last production is found to be defective. What's the probability it came from? A. So they're asking you to find the posterior. They can't ask you to find this one, it's the opposite. Posterior is simply the reverse. It's A given D. So you can't find A given D before finding the defective. We already did that. A given D is here. So the answer that you get here, 0.375, is the answer you use there. Okay. So we'll end here for tonight. I will send you questions just exactly what we've just done here. Those of you who don't have my number yet can inbox me so that I give you a group link to join. All right, we are preparing for the exam, so you can inbox me